This video is brought to you by Squarespace, the tool to use to make a website for your brand or business. More about them in a bit. It's July of 1994, and the world is watching in awe as doomsday approaches. Across the night sky, 21 points of light are stretched out in a line, fragments of a great comet that broke apart into chunks several kilometers across. Now they head on a collision course with the planet's atmosphere, an unstoppable freight train of death, bringing the apocalypse in their wake. Finally, it happens. One by one, they plunge through the skies over a period of 6 days. 6 days in which a force equal to 300 million nuclear bombs is unleashed. Thankfully, of course, it isn't our planet that stands in the firing line. Rather, it's the biggest in our solar system, Jupiter. And the comet that's just caused such destruction will go down in history as Shoemaker Levy 9. Discovered in the spring of 1993 by Eugene and Carolyn Shoemaker and David Levy, Shoemaker Levy 9 was one of the great astronomical events of the 1990s. For the first time, we witnessed a comet impact another celestial body. Yet those spectacular July days were also a warning, a vision of the destruction that could one day be visited upon our own world. It was March the 24th, 1993, when Carolyn Shoemaker sat with her husband Eugene at the Palomar Observatory in California, unaware that she was about to make history. The two had met 43 years earlier at the wedding of Carolyn's brother. A young California girl and a Caltech geologist, they had a joint interest in astronomy. Married in 1951, they spent years as a regular mid-20th century couple, Carolyn staying at home while Gene worked. But when they found themselves presiding over an empty nest at the dawn of the 1980s, this lifestyle no longer seemed enough. Determined to find a new passion, Carolyn joined the astronomical branch of the U.S. Geological Survey. Soon she was at the Palomar Asteroid and Comet Survey, known as PAX, studying the night sky for signs of comets that might pose a threat to Earth. At the time, PAX was considered a somewhat eccentric program. While the theory that an asteroid had barbecued the dinosaurs was gaining traction, only a handful of people seemed to put two and two together and realize that, well, it could happen again. This meant years of working in obscurity, of painstakingly examining plates taken by the Palomar-Schmidt telescope to look for traces of moving objects, while the rest of the world obsessed over more important stuff like new Coke or whether VHS was really better than Betamax. Yet, obscure doesn't mean unsuccessful. By 1993, Carolyn Shoemaker had discovered 31 comets, widely thought at the time to have been the most discovered by any individual. At some point, she'd begun working in a team with Eugene and the astronomer David Levy. Together, they'd located 8 separate comets, the most recent, Shoemaker Levy 8, in April 1992. But it would be their 9th joint discovery that caused their names to go down in history. On that fateful night of March the 24th, 1993, Carolyn noticed something strange on one of her plates. There before her was an image of a wispy, elongated line stretching out as comets often do. But while most comets stretch from head to tail, this one stretched vertically. Although it did have a tail, it was the head that dominated the image, a weird line in space. Now, this was super unusual. The most compact part of a comet, the head, is normally a solid chunk of ice and rock. As you probably remember from seeing Neowise in 2020, it usually looks like a dense, glowing ball. In other words, extremely unlike the image Carolyn Shoemaker had before her. Looking up, she told Eugene, "I don't know what I have, but it looks like a squashed comet." It was the first sign that a spectacular disaster was about to befall the outer solar system. Because the distant comet was so faint, about 1,000 times dimmer than the naked eye can see, that it took another professional to confirm the sighting, James V. Scotti at the University of Arizona. But confirm it he did, not just its existence, but also how utterly strange it was. Before the month was out, the Shoemaker's discovery had been provisionally named 1993E, indicating it was the 5th comet to be found that year. Later it would be rechristened with the incredibly boring designation D/1993F2. However, it would be under a much more memorable name that it became known to the world: Shoemaker Levy 9. Normally, comets come in a couple of easily understood flavors. The first are short-period comets. These are the ones that originated in the Kuiper belt and have an orbit that swings beyond Neptune and back again on a relatively quick journey that lasts less than 200 years. The most famous is Halley's Comet, which visits our skies once every 75 years or so. The second are long-period comets. These are on epic treks across the gulfs of space, with orbits that take them impossibly far from the sun. Comets like Hale-Bopp, which last appeared in 1997 and will next pass Earth in 4385 AD. Now, these aren't the only types of comets. There are subdivisions between the various short-period comets, and in 2018 we located our first interstellar comet, 2I/Borisov. But Shoemaker Levy 9 appeared to be something else entirely, a weirdly shaped thing on a weird orbit that took it extremely close to Jupiter. In fact, the comet passed so close to Planet 5 that it soon became clear that it wasn't orbiting the Sun, but the gas giant itself. It was swinging around on a 2-year path like a persistent summer mosquito buzzing incessantly around your head. It was this discovery that provided the key to Shoemaker Levy 9's weirdness. The more astronomers studied the elongated comet, the more its backstory began to emerge. It turned out that SL9, as it became known, had once been a regular comet, if a one on the larger size. With a diameter of 9 kilometers across, it had been just a hair smaller than the asteroid that dramatically blew up the age of the dinosaurs. And it was doubtless equally odd. The most likely scenario had it that SL9 had been zooming through the solar system for billions of years, orbiting the sun unnoticed by anyone, just another dancer in the great cosmic ballet. But then, in the mid-20th century, it had wandered too close to Jupiter, and all hell had broken loose. Exactly when SL9 got caught in Jupiter's gravity trap remains a matter of speculation. Most sources we looked at assumed it happened in the 1960s or 70s, although one article seemed weirdly insistent on the idea that it had happened in the 20s. Whatever the exact timeline, the fact remained that it had been captured by the planetary Big Daddy, pulled into a strange, elongated orbit, one that could only ever end in its destruction. Less than a year before Carolyn Shoemaker first saw its image on the Palomar Observatory plate, SL9 had swung dangerously close to Jupiter. Dangerously because at this distance, the immense tidal forces acting upon it had simply been too much. 40,000 kilometers above the Jovian skies, SL9 had been pulled apart as surely as a bug in the hands of a sadistic kid. But rather than violently shattering, with each shard spinning off into a new direction, the disintegrating parts of Shoemaker Levy 9 had continued to interact with one another, thanks to some highly complicated orbital mechanics that we don't even pretend to understand. The fragments wound up strung out in a line of cometary chunks, many over a kilometer across, howling through the void. It was this strange line that Carolyn Shoemaker had seen. What she thought looked like a squashed comet was actually one that had disintegrated. As astronomers worked to understand SL9, it became clear that its orbit wouldn't continue much longer. Rather than remain circling the gas giant as a new moon, the comet was already doomed to crash into Jupiter in July of 1994. And for 1990s dudes, that was huge news. Never before had humanity directly observed a comet hitting another celestial body. And with Jupiter in this era still relatively understudied, the impact would allow scientists to learn all sorts of crazy things about our distant neighbor. In May 1993, the Central Bureau for Astronomical Telegrams announced the upcoming impact, then a mere 15 months away. It was the starting gun on perhaps the craziest race of all time. The race to ensure humanity got a front row seat to Armageddon. Now let me interrupt this video to quickly tell you about one of our long-time sponsors, Squarespace. Now you've heard me talk about them before, and honestly, if you're making a website anywhere else in 2022, well, that just seems a little bit insane, doesn't it? Because Squarespace have all of the tools you could ever need in one place. And not only that, but that place is super easy to navigate and make a website from. All you gotta do is head on over to Squarespace, and from there, the next step, for those who want to be quick, is to browse through their extensive selection of templates. And they make this super easy. They ask you, well, what is your site about? And you say something like photography for me. pursuing my dream of becoming a professional tiger photographer. And then they ask you about your goals. And there's lots of options from collect donations to, following the tiger photography example, sell your services. And then they show you the best matching templates. You pick the one that you love, take your time. There are loads of good options. And then boom, it's up and running. And you just use their ultra simple editor to change it for your needs. You can add pictures, add pages, change the text, pop a portfolio in there, whatever you want, it's all good. And then there's lots of other features that you can use. For example, pop a little email form on your site for people who might be interested in your business and follow up with an email campaign. Easy, bound to increase your sales. And of course, it's also got all the basics like analytics and blogging tools. There really isn't a better and easier place to make a website. Head to squarespace.com for a free trial, and when you're ready to launch, go to squarespace.com/geographics to save 10% of your first purchase of a website or a domain. And now back to today's video. All things considered, Shoemaker Levy 9 couldn't really have come at a better time. By mid-1994, there were a spectacular number of probes and telescopes out in space that could watch its demise from all sorts of angles. Way out beyond Jupiter, Voyager 2 was able to capture what was happening on its UV spectrometer. Closer to the Sun, the Ulysses Probe was primed to measure radio waves. Then there was the Hubble telescope, freshly repaired in 1993 and ready to capture sharp images of the collision. But perhaps luckiest of all, there was Galileo, a NASA probe designed to study Jupiter in depth. Galileo had launched in 1989. Now, as summer of 1994 began, it was well on its way to Planet 5, meaning it could study the impacts from a frighteningly close position. On top of that, the force of the crash was predicted to be so vast that even amateur astronomers would be able to witness it with little more than a basic telescope and some clement weather. In short, July 1994 began with every single space geek on Earth primed to have a grand old time. The one exception to this was Carolyn Shoemaker, who admitted to being a bit depressed about SL9's upcoming destruction. To quote, "I'd never lost a comet before. All my comets, I knew where they were, but this one, I was going to lose." Still, she wasn't the only one feeling a tad disappointed. Thanks to a universal constant known as Sod's Law, all 21 fragments of Shoemaker Levy 9 were destined to impact on the far side of Jupiter. While we'd get to witness the aftermath, the blasts themselves would be invisible. So everyone thought. The apocalypse finally began on July the 16th, 1994. Just after 8 p.m. Universal Time, the first fragment of SL9 stumbled into the Jovian skies. Dubbed Fragment A, with the second tip being called Fragment B, and so on, it was also one of the biggest. At over a kilometer across, it simply dwarfed anything we've ever seen hit Earth. Remember the Chelyabinsk meteor that exploded over Russia in 2013? It's estimated that that was a mere 20 meters in diameter, and it was still enough to blow out windows, damage buildings, and injure 1,500 people. So when Fragment A came screaming through the Jovian atmosphere at 60 kilometers per second, its kinetic energy was off the charts, and that meant the subsequent explosion was something else too. The energy unleashed by Fragment A's impact was equivalent to over 60,000 Castle Bravo hydrogen bombs detonating at once. The result was a plume of material so vast it rose above the Jovian horizon, briefly becoming visible even to those watching from Earth. Yet it would be the aftermath of this blast which really proved the most spectacular of all. Within minutes of the impact, Jupiter's top cloud rings had turned enough for the crash site to become visible. What had once been an unblemished swirl of cloud now sported a great ugly scar, one so vast it could have swallowed our planet whole. When pictures of the scar came in over the Hubble telescope, it prompted a now famous moment. Captured on video, crowded around a monitor, the Hubble team all seemed to have had a simultaneous science-gasm. To this day, their collective freak-out remains perhaps the greatest reaction shot ever recorded. And this was only the beginning. Over the next 6 days, another 20 fragments of Shoemaker Levy 9 were going to smash into Jupiter, together releasing more energy than 300 million atomic bombs. For astronomers across the world, the best was yet to come. Once they gotten started, the impacts on Jupiter became relentless. For the better part of a week, comet fragments took turns hitting the gas giant at ungodly speeds, each one massive enough to instantly obliterate all life on Earth. In nearly all cases, the results were spectacular. Each fragment superheated the atmosphere to 40,000 degrees Celsius. Each one resulted in a plume of material about 3,000 kilometers high, or to use a more colorful unit of measurement, equivalent to 340 Mount Everest stacked one on top of each other. Even amid this spectacular light show, though, there were still moments that stood out. Perhaps the most outstanding was the impact of July the 18th. At around 7:30 a.m. UTC, the largest fragment of all came crashing into the Jovian atmosphere, setting off a reaction so violent it made that caused by Fragment A look like a planetary hiccup. Known as Fragment G, its destruction triggered a flash of light so bright it briefly outshone Jupiter itself. Powerful telescopes pointed at the blast had their instruments scrambled, unable to even measure its intensity. Meanwhile, amateur astronomers watching from their backyards were able to see a flash even through comparatively weak telescopes. Blinding as it was, Fragment G wasn't the only major show. Fragments K and L were also enormous, with the three of them together making up perhaps 75% of Shoemaker Levy 9's original mass. Each of these heavy hitters left scars in Jupiter's atmosphere. Each sent plumes of dust spreading through the skies like evil tendrils, and each of them yielded reams of scientific data unlike anything we'd ever seen before. With all of that dust now dispersing through Jupiter's atmosphere, scientists were able to track its movements and thus learn how wind moves on the gas giant, how its currents circulate, and at what speeds. At the same time, monitoring the impact gave us a window into what makes up the comets themselves, into their internal structure. In short, it was a primetime show for the general public. For actual scientists, though, it was a data goldmine. The final impact came on July the 22nd, 1994. That day, Fragment W plunged into the atmosphere, marking the final destruction of Comet Shoemaker Levy 9. But while the bombardment may have ceased, the effects on Jupiter had not. In the initial aftermath of the impacts, the most notable change was the scars that remained visible on Planet 5. Although they eventually dispersed, it was only after literal months had passed, months in which they were as plainly visible as the Great Red Spot, the giant Jovian storm that's been raging for hundreds of years. And when they finally faded, it was clear Jupiter was still suffering the after effects. Elevated amounts of ammonia remained detectable in the atmosphere until late 1995, but even this had nothing on the water. Because comets are such icy bodies, they release water vapor when they go kaboom. It's theorized that early comet impacts were responsible for Earth's oceans. While Jupiter is way too unlike Earth to have its own seas, scientists did notice a vast spike in water vapor in its atmosphere after SL9 hit. In early 2013, an ESA study calculated that as much as 95% of all water vapor on Jupiter likely came from this impact, and it's still there. As late as 2020, water from the comet was confirmed to still exist. Physically, too, Jupiter suffered long-term consequences. The planet's main ring is thought to have inherited a tilt of 2 kilometers from the impacts that led to ring disturbances that were recorded right through into the mid-2000s. If that doesn't sound so long, remember how unbelievably gargantuan Jupiter is. It's big enough to fit 1,300 Earths inside. Now try to imagine what sort of force would be required to mess with something so big. Even God himself couldn't mess with it. In short, Shoemaker Levy 9 was the mother of all Jupiter impacts, and even though we've since witnessed others, about 11 in total, they don't come close to what happened in 1994. Not even the 2009 impact that briefly left a scar the size of the Pacific Ocean. Yet just because the visual evidence has long gone doesn't mean Shoemaker Levy 9 isn't still influencing the world we live in, because there was one other great lesson NASA took from that summer in 1994, aside from, wow, cool, space fireworks. And that's the idea that if an apocalyptic comet can hit Jupiter out of the blue, then what's to stop one hitting Earth? On June the 30th, 1908, a streak of light dropped out of the sky above the Tunguska River in the wild heart of Siberia. Inside the fireball was an asteroid, one estimated to have been about 100 meters in diameter, but we'll never know for sure. 8.5 kilometers above the ground, the object exploded with the force of 10 megatons of TNT. In an instant, a stretch of forest the size of Rhode Island was flattered, great thick trees scattered like matchsticks. 60 kilometers from the blast, people were knocked off their feet. Hundreds of kilometers away, windows rattled with the shockwave. The Tunguska event remains the largest meteorite impact recorded in human history. It's only thanks to it hitting Earth in the remotest part of Siberia rather than above a bustling city that it didn't manage to kill anyone. Of course, people in the mid-1990s knew about this, but they filed it away simply as one of those things like, well, I'm glad I wasn't standing there. But then humanity watched as Shoemaker Levy 9 crashed into Jupiter, 21 fragments, each significantly larger than the Tunguska meteor, hitting a planet one by one. And that raised a terrifying question. What would we do if we found a similar comet headed for Earth? What could we do? The terrifying answer was not a lot. It seems incredible now, but in 1994 only a handful of people, the Shoemakers among them, were working on tracking near-Earth objects, NEOs, to try and identify future hazards. The term planetary defense didn't even exist. While movies like Armageddon may have assured us that we could just send Bruce Willis up there to deal with it, the reality was that we probably wouldn't have known about a doomsday impact until moments before all human civilization vanished in a flash of light. It took the fireworks display of SL9 to shake us out of our complacency. But shake us out it did. In 1998, US Congress passed a bill championed by Eugene Shoemaker, directing NASA to start a comprehensive search for all local NEOs with diameters over 1 kilometer. It was a hell of a job, one that the agency took until 2010 to complete. By then, though, it was already clear that wasn't enough. With 90% of NEOs over 1 kilometer catalogued, NASA began to pivot to an ongoing project to find all objects over 140 meters, hopefully all the Armageddon asteroids out there. Now, that will still leave Tunguska-sized meteors uncatalogued, each big enough to reduce a Sirius-sized city to ash, but at least it takes care of the civilization killers. And at least it's woken the world up to the possibility that this could happen again one day. Better still, SL9 paved the way for perhaps one of NASA's coolest current missions. DART stands for Double Asteroid Redirection Test, which sounds incredibly boring until you realize what the agency actually means by that. Launched in November 2021, DART is, depending on when this goes live, either currently en route to a potentially hazardous asteroid known as Didymos, or has recently arrived. Now, Didymos is an interesting asteroid in that it has its own moon, a tiny little space pebble known as Dimorphos. It's the 170-meter Dimorphos that is DART's target. And the plan? Crash the probe into it at over 23,000 kilometers per hour in the hopes of changing its orbit. The idea is that DART will prove or disprove our ability to knock a killer asteroid off course. As such, it's NASA's first planetary defense test, an important stepping stone to protecting ourselves from future Tunguskas. And it's all thanks to Shoemaker Levy 9. Sadly, while David Levy is still alive, neither of the Shoemakers will be around to see it. A mere 3 years after the fireworks display on Jupiter, the Shoemakers took a road trip through Australia to study the remnants of ancient impact craters. Outside Alice Springs, another vehicle plowed headlong into theirs, killing Eugene Shoemaker instantly. While Carolyn Shoemaker survived, it was with serious injuries and a great hole in her life where her husband had once been. She finally passed away on August 13, 2021. She never remarried. Yet the story of the Shoemakers and space didn't end with their deaths. In early 1998, NASA was preparing to launch the Lunar Prospector probe to the moon. With Eugene Shoemaker's tragic death fresh in everyone's minds, the agency decided to honor him in the most epic way possible. When Lunar Prospector launched, it carried with it a specially designed capsule, one containing Eugene's ashes, and inscribed with a Shakespeare quote, "And when he shall die, take him and cut him out in little stars, and he will make the face of heaven so fine that all the world will be in love with night, and pay no worship to the garish sun." In mid-1999, Prospector was deliberately crashed into the lunar surface, ending its mission. The impact left Shoemaker's ashes buried in the lunar regolith. To this day, he remains the only person buried on another celestial object. So that's the story of Shoemaker Levy 9, of the comet that we only knew for a little over a year before losing it in a spectacular impact. But while SL9 may have gone, its influence undoubtedly remains, not just in programs like DART and NASA's attempts to find all potentially dangerous NEOs, but also in how we understand the solar system and our place in it. How fragile it revealed humanity to be, how in need of a backup in case a similar comet ever comes for Earth. We may not yet have that backup, but if the memories of SL9's destruction eventually inspire us to take our first steps as an interplanetary species, then we can safely say that its effects will remain with us for all eternity.